Hello friends, welcome to video number 20 or question number 20 of the DSA practice group. In this video, we are going to deal with question number 20 overall or question number 2 for Qs. And before that, let me introduce you about the DSA practice link which must be flashing down below. You can click that link and join the group where the practice is being done. So basically, regularly a question is posted for people to practice, right? My students practice those questions, they try out those questions by themselves, think of different kind of logic, the different time and space complexity and all different ways of doing that. Sometimes they're able to do by themselves, but if they are not, they're getting stuck, they can always message me anytime and I'm able to reply to them whenever I get time and help them overcome it, right? And in case even after a long period of time, maybe around 24 hours, if they are not able to do the problem by themselves, I post solutions like this video, right? Sometimes I post just tips and tricks, sometimes I post solution videos, which is basically a discussion of the problem along with a solution, and they can watch that and progress ahead, right? And with the help of this, they are able to practice DSA and master it so that they can earn 12 to 30 lakh INR, right? 12 to 30 lakhs INR per annum, even in India, even when they are freshers, even when they don't have any kind of experience. Why? Because they become masters at data structures and algorithms, right? And most of you would already be knowing this. DSA questions is what tech giants like Amazon, Microsoft, Google ask, right? So in this video, I'm going to help you practice this data structures and algorithms, and I'm also going to give you a lot of tips, a lot of insights on what is the best way of mastering these questions so that you can clear these tech giants, clear these interviews, and be able to go ahead at a rapid pace, right? Trust me, it is possible for anyone, right? It's a learnable skill. The ability to solve problems is a learnable skill and anyone can do that. Okay, and who gives me the authority to say something like this? So let me tell you about myself. My name is Akshaya. I am from IT Delhi BTech Computer Science graduate, having worked at Amazon and Paytm as software engineer, senior software engineer. I have cracked interviews of a lot of other companies with a high success rate, like almost like 100% success rate. This wasn't the case always, right? Even when I came from IIT, I struggled clearing these interviews because I didn't know the strategy. I used to study everything out and I used to believe that because my CGPA is not really awesome, I may not get those. So I didn't have that confidence. But after a while, after probably my first job, yes, after my first job, I came across this formula. I came across the importance of data structures and algorithms and I fell in love with them. I fell in love with problem solving and I also fell in love with the different kind of techniques, and I developed my own method which enable not just me to be able to crack any kind of interview of tech giant of any product based company, but also help me create a formula using which I can help anyone, probably anyone which has no background at all, crack these companies in 1 to 3 months, right? And because of this, some of my students have also cracked companies like Microsoft and Paytm and are working at very healthy packages, right? And some of them have done that also in just 1 month's period of time, even when they had been struggling so lot for a long period of time during their bachelor's, during their master's, spending time trying to understand things by themselves. But when I brought this special formula, this model in front of their eyes and helped them master that, they were able to do so in just 1 month period, right? So don't delay, click on the link, join the practice group, get in the momentum and get going, right? And if you are outside India, then also this is going to be hugely helpful to you because you already are aware of this, that companies like Google have already taken off that requirement of even having a degree for getting a job over there. What they are really concerned is about your ability to think, ability to solve problems, ability to deliver results, right? Because from the results and from the products is what these big giant tech companies work, right? So if you're able to provide that input, that results to them, provide that revenue to them, they can of course share a small part of that revenue with you. That's why these companies are focusing on problem solvers, ability to think properly, right? And because of that, you can earn from 100k to 200k US dollars at a tech giant if working outside India, and that too if you can just practice for a short while and master these thinking skills, right? So click on the link and join. Okay, great. Now let's jump to the question. This is question number 20 of the entire practice, right? Or you can just say question number 2 of the Qs. This question is pretty much simple for someone who has memorized the solutions, right? So I would say don't do this problem by just memorizing the solution. Try to think and try to learn from this video how I actually solve this problem so that you can apply the same principles on any other problem, right? And this is just like a warm-up question, so don't get stuck in just solving this. Try to go behind the words that I'm saying and try to understand how you can apply the same knowledge, the same tricks, the same insights at solving any other problem, right? So let's try to understand what is the importance of data structures and algorithms, right? The importance of data structure and algorithms is basically storing the information that you want in a way which can be easily accessed, can be easily modified, can be easily edited, right? Depending upon the requirement of the question, these information should be able to be processed under certain constraints, right? For example, let's say you want the data to be accessible in very fast time, right? So you would have to write a code which takes probably order one time. Sometimes you want the speed can be okay, but you are very concerned about the memory, right? So then you will have to optimize the memory. So as a result, you should be able to think on this regard also, that how do you manage the different constraints such that your solution still comes and it is the best possible, and at the same time be able to prove, right? So there are a lot of fundamentals which go around solving even a simple problem like this, right? And when I solve this, I'm going to apply all these techniques in my mind so that I can come about the beautiful solution to you, right? And you should also try and follow the same habit, that you master those basics, right? The master those basics, those secret basics which I'm talking about, and then apply those techniques at solving these problems. Okay, so let's dive into this. Design circular queue. Great. So what is a queue? You must already be knowing from your real life that queue is a place where someone who's standing at the front goes in first, then a second person goes, and a third person, and so on, right? So same thing applies in a queue in computer science, right? So basically you create the information and store that in an order that the information that came in first will go out first. That is a basic definition of a queue, right? The queue definition is a very abstract thing. It's an abstract data type. Depending upon how you implement it, depending upon different ways of implementation, your queue code will be different. But that's not what a queue is. A queue is an abstract data type. That's what it is, right? And there can be a lot of ways of implementing. I'm pretty sure a lot of you would have used different ways. If already tried this problem, you would have different mechanisms of solving this queue, right? Maybe probably by using array list, but I'm going to break it down into a simple thing that you forget about any kind of data structure, queue, stack. Just focus at solving the problem, the demand which is being asked by the question, and solve it according to by creating a new data structure of your own, right? That's the real thing that is needed for a person who is good at data structures and algorithms. So we are going to see that in a short while. Okay, and what is a circular queue? Okay, so normally we understand the queue is a straight line, right? Something which is at the beginning goes out first, the something which comes at the end goes out last, right? Now, when you are storing this information in computer science, we know that memory is limited, right? So let's say if you use an array to implement a queue, right? So let's say the array goes from index 0 to maybe n, right? Goes from 0 to n, and it has n plus 1 elements at max. So when the first element comes in, it will be stored at position 0, the next element at 1, the next element 2, and so on, right? And similarly you can probably go to index n, right? So when all the elements are there, n plus 1 elements are there, all the indices from 0 to n plus n are covered. But let's say the first 3 elements get removed from the array, right? Because they came out first, the index 0, 1, 2 will get removed first, right? While the remaining ones are still there, and we need to maintain this order. Now let's say a new element wants to join in the queue, but we will say that this element cannot join the queue because there is no space. you will say there is some space at the beginning of the array, right? Then why can't we just put that element at the beginning? The problem is, if you put the new element at the beginning, the property of the queue, the abstract data type of the queue which is defined about the order is lost, right? The last element which comes in cannot be present at the beginning. It has always needed to be present at the end, but there is no space at the end, right? Because of this, the new element will be rejected, right? Even when there's a space at the beginning, the new element will be rejected. So a probable solution of this is that you take the entire array from index 3 to n, copy it to index starting from 0, so that 3 spaces become vacant towards the end of the array, and over there you can put the new element. Okay, but because of this, the time complexity is going to explode, right? Because every time a new element is going to be inserted and the array is finished, you will have to copy the entire array to the beginning, right? So that can be a problem. So a solution to that, which is figured out is to use the array but using it in a circular fashion, right? So what do I mean by circular fashion? In a circular fashion, the counting is like a modulo arithmetic, right? Which basically means, let's say we have the array starting from 0 and it goes to index n. Now the queue doesn't stop at end. The next element can come at n plus 1, which in modulo n arithmetic is 0th index, right? So if the 0th index is empty, we can put the next element from n at 0th index if it is empty, right? So remember the example which I gave you at the beginning. When 3 elements have been deleted from index 0, 1 and 2, and the rest of the elements starting from 3 up till n are filled up, now a new element comes in, let's say n plus 1th element. Now this can be stored at the 0th index, and when a new element comes in, it can be stored at the first index, right? And we know that the order is maintained because we will be following the ordering, right? Instead of starting from 0th index, we will start from index number 3, we will go to n, then we will go to 0th index, then first index, right? So in this way we have saved upon we have utilized the extra space which is available at the beginning of the array, and this can go on and on infinitely uh, till elements are getting inserted and deleted. But there's only a very small problem with this kind of a data structure, that you have to specify the length of the array in the beginning, right? You have to tell what is the size, maximum size of the queue, so that you can define the size of the array. Okay, in the solution which I am going to give you, I am not going to even use an array because it is not needed. Though the question asks though the question gives you that information probably about the size, the maximum size, but I am not going to use it, and I'm going to create a very basic data structure which will resolve all your problems. Okay, so let's try and understand the question even further. Design your implementation of the circular queue. The circular queue is a linear data structure in which operations are performed based on FIFO, which is first in, first out, and the last position is connected back to the first position to make a circle. Okay, it is called as ring buffer. Great. One of the benefits of circular queue is that we can make use of the spaces in front of the queue, as I just explained to you. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in front of the queue. But using the circular queue, we can use the space to store new values, as I just said, right? So I right now spend a lot of time in explaining you the problem. Most of the people skip this step. Okay, when I'm creating a video, when I'm trying to explain to you, it is taking a lot of time. But when I will be actually doing a problem, it will take me much less time, right? Maybe 10-30 seconds, 1 minute, right? But I will be making sure that I actually understand the problem. When you're beginning to solve, when you haven't cleared any interviews yet, right, start giving at least 5 minutes on understanding the problem. Once you develop that habit of going thorough at understanding the problem by giving a proper amount of time, maybe taking a lot of time to understand that problem, that process will become automated, and you won't take 5 minutes or 10 minutes to understand the problem. Probably in just 30 seconds you will be able to understand, right? But to come to that level, you will have to begin by giving 5 minutes or 10 minutes at probably understanding the problem. Okay, once you have become master at that, then you go ahead, but till the time you have not, practice like this. Okay, so keep practicing by understanding the problem better. Great. You know why I'm saying this? Because if you miss that point, it's going to leave a bad impression on the interviewer, right? Second, you are going to spend a lot of time trying to solve a problem in the wrong way. Because you don't even understand the problem, your solution won't be a fit, and you will learn it the hard way when a lot of test cases fail, right? So don't go for randomness. Don't try for a fluke. Give some time, give certain amount of time, be certain what the problem is asking, and then perform your code and see what comes. Great. So your implementation should support the following operations. One, my circular queue k, which is basically the constructor. Okay, and it sets the size of the queue. Great. Front, get the front item from the queue. If the queue is empty, return -1, right? The -1 basically states that the queue is empty, so that a person doesn't use the output as a wrong answer, right? Similarly, you have rear, which basically means the end of the queue. Get the last item from the queue. If the queue is empty, return -1. Great. Then we have enqueue, input value, which basically inserts an element into the circular queue and return true if the operation is successful. If the queue was probably already full, then you should return false, right? Then we come to dequeue, delete an element from the circular queue, return true if the operation is successful, is empty, checks whether the circular queue is empty or not, is full, checks whether the circular queue is full or not. Great. Now comes the interesting part. Okay, if this question is given to you by the interviewer in face to face, you should make a circular queue. Okay, you should make a circular queue. But if you are given this question in an online round, right, and you're doing for practice, or maybe it's an actual round, you don't have to follow all the instructions given in this question, right? For example, in this question it says create a circular queue, right? But there's no way of identifying if we are using a circular queue. The circular queue is needed only when you have an array being used. What if I create a basic data structure without using array, and that need not be circular but will have all these operations, and it will have an order, a very beautiful or very less order? That's what I'm going to show you, right? So it is very important, don't fix on to the way of solving problems, but break open that pattern in mind and come up and see what is the best way of solving the constraints that are given. These are the constraints, and for this I'm going to put forward a beautiful solution without using an array. Okay, so let's just first go through the code also once and see what is there, and then I will copy paste the code which I have already written, which we will discuss. Great. So over here we have the constructor, then we have the boolean of enqueue. You're going to basically insert the value into the queue, insert element to circular queue, and insertion in a queue always happens at the rear end, right? Return true, the operation is successful. Then dequeue, basically remove the first element from the queue, and if you are able to do so, return true, otherwise there's a false, right? And front, it basically returns the front of the queue without removing it. Rear, it returns the last of the queue without deleting it, right? Boolean is empty basically tells if our queue is empty, and is full tells whether we have reached the size k. Okay, so as you can see, nowhere there is a restriction in the code to use an array, right? So I'm going to perform all these operations without actually creating a circular array, circular queue. Okay, and you will see the code passes as well. So let me just copy paste this code. Great. So before we jump on to this question, I want to just give you a slight hint. Okay, if I try to explain everything to you, this probably might take 5 or 6 hours, because everything from proving, everything from how I'm thinking, what are the logics involved, what is the way to optimize the code, what is the way of comparing different data structures, it will take a lot of time. But let me just emphasize and focus on telling how to approach this, right? So whenever you are given these functions, try to think these as the rules or constraints of the problem, and think what is the property, what is the thing that this is supposed to do. Obviously over here it is very easy, right? This basically means constructing, this basically means enqueuing, this basically means dequeuing. But think in terms of pseudocode, that what this operation will actually be doing on the basis of the data structure that I create, right? For example, if you are using an array, what all must be maintained throughout, right? There's something called like an atomic operation in databases, which basically means the entire operation must occur in a way that during the process certain rules of the database are not followed, but towards the end and before the operation all the rules are maintained. You have to ensure these operations also work in the same way, that certain properties of the circular queue are always maintained, so that you can forget about every other function. Like while working on enqueue, you can forget about what dequeue does, you can forget about what front does, what rear is doing, but just maintain the property which was present before enqueue was called and after enqueue was called. Okay, so let's go to the code and see. Okay, so what we basically need was a kind of a data structure which can hop elements, right? For example, when we want front, right, for that front we can probably use the top of the linked list, right? And for the rear we can probably use the tail. Okay, but there will be a problem in this. The problem would be that insertion on the front is easy because the head is present over here, so there won't be a problem. But when you try to delete the tail, you don't have access to the previous of the tail node, and because of this the tail node cannot be removed. And because of this, if you are using a data structure like node, which is capable of performing hopping with the help of next node, you would have to keep the tail of that linked nodes as actually the front, while the head as the rear, because of insertion and deletion. Okay, so let's jump into the code and see. So first thing over here, my circular queue int k. So you need to assign max size equal to k. No other property need to be maintained when you are in this constructor, right? Because there's no other information coming, and you need to store this so that you can identify when the circular queue is supposedly full, right? So that's why I have saved max size equal to k, and that's why I had created this variable max size. Great. Next we come to enqueue. Now let's try and think of the pseudocode for enqueue int value. What is it supposed to do? When enqueue is being done, the new value which is coming in must be stored at the tail of the queue, right? Which in our case would be actually like the head of the queue. Okay, and before adding that, we are going to check whether the queue is already full or not with the help of max size. If it is not already full, then we can add. And how we will add? We will add by using simple operations on this node, right? So let's see. So if size is equal to max size, we know that queue is already full, so we will return false. Okay, but if size is not full, then we will have to insert. Now if we have to insert, then there are two scenes possible. One is if the list or the queue is already empty, and the other is if it has some elements. If it is empty and if it has elements, the two cases are different, because in the case of empty, lot of variables like the head and tail won't be initialized, so you will have to initialize them, right? So over here, if size is equal to 0, I created a new head node and I assigned the tail and head to the same because there's only one node, and I assigned size is equal to 1 and return equal to true, right? So when I'm assigning size equal to 1, why is that necessary? So this will give you certain insights about the properties of the data structure which are need to be maintained. And one of those properties is size. Always tell what is the size of the queue. And that's why I'm ensuring the size is maintained. Similarly, I'm maintaining certain properties here also, which we will come in a short while. But don't get uh, don't get confused or disheartened if you are not able to understand it completely, because right now it's very hard to explain. You probably have not done a lot of basics, right? So I'm not going into that because it will just complicate and explode the video, but I'm just giving small insights. Okay, so if size is equal to 0, you can perform this, right? Now it will come over here when there is at least one node, and when there's at least one node, when the new nodes comes in, it will be inserted at the tail of the queue, which is basically actually the tail, right? So what we will do is tail dot next is equal to new node. Okay, and this tail is actually the head of the queue, right? Head of the linked list. No, this is actually the tail. So tail dot next is equal to new node and tail is equal to tail dot next, right? So if our queue was going from, let's say, this direction to this direction, okay, where this is the head and this is the tail, this tail actually represents the element that had come last. And that's why what we are doing is tail dot next is equal to the new node with the new value which has been given over here. And as soon as we do that, as soon as we add this element over here, we will do size plus plus, right? So here also you must pay special attention and see that I'm adding the new element at the tail, right? And there's a very special reason of doing so, because from the tail we cannot delete the element, right? We cannot delete the element, but only from the head of a linked list can we remove. And that's why the first element has been kept at the top because it is easier to delete. At the tail you cannot delete, right? So that's why this is like the rear. Okay, great. And then we will do return true. Great, everything is maintained, the properties are maintained, so this will be done. Of course there are a lot of mathematical proofs which I am doing myself, and when I was writing the code I had done that, which helped me understand that this code is working. And it does take a lot of practice, so don't be disheartened. Delete an element from the circular queue, return true if the operation is successful. Great. So we have to remove an element. Now if the queue is already empty, we will return false, right? So we can simply do that. Now comes the case if there is if there's exactly one element or there can be more. And why do we need to distinguish between the two? We need to distinguish between the case when the queue has only one node and more than that, because when there is only one node, the head and tail are the same, right? So even if one node is removed, both head and tail have to become null, which in normal cases is not the case, right? So that's why when size is equal to 1, I am assigning head is equal to null, I am assigning tail is equal to null, I am assigning size is equal to 0 and returning true, right? Over here, why head and tail have to be set up null? It's also the same thing, which is about maintaining the certain properties of the queue as true, because if this fails, then the other operations of the queue will fail, right? For example, over here in enqueue, we had assumed that the head and tail, we had not written a special case to check when size is equal to 0 whether tail is already null or not, right? So that's why it is important that we assign tail and head as null so that all the other functions can forget about it and do. Great. Now when we come to this line, this basically means that there are no 0 nodes, there are no 1 nodes, and there has to be at least 2 nodes, which basically means head and tail are very different. So now what you can do is from the head you can remove the element, and that is very easy. What you have to do is head is equal to head dot next, and automatically this thing gets removed, right? And that's why we kept the head of the linked list as a place, as a front of the queue. Probably in the beginning of the video I kind of mixed the two things, but right now I am clarifying that the head of the linked list is actually the head of the queue also, because it makes it easier to delete from the head. Okay, so that's why head is equal to head dot next, size is minus minus, and return true, and we are done. Great. Now the other problems questions are going to be very easy. These were the main things that you have to take care of, NQ and DQ. The reason being, this is basically changing the structure of the data. All these other functions are like accessing the information. So if you have ensured the properties of data structure of the queue is maintained in the execution of NQ and DQ, you can be sure that these functions are working perfectly fine, right? So when you come to front, all you have to do is return the value of the head node, and before returning you have to just check whether the queue is already empty. If it is already empty, you will return -1, right? So that's what I did. If head is null, return -1, otherwise return head dot value. Similarly for the rear, if head is already null, return -1, otherwise return tail dot value. Great. And then we are left with two functions, which is boolean is empty, which can be tested by head is equal to null, or you could have even checked for size is equal to 0, and is full can be tested by size is equal to max size. Great. So in this entire question, I didn't use an array and I didn't maintain a circular queue, but I'm able to perform all these operations, right? Creating a circular queue with an array would be relatively easy, so you can try it by yourself, right? Many of the students which are already in the group have done that, so great job, good. Now when you have watched this video, push this video aside and try to do the same thing which I did by yourself and time yourself. Right, keep a stopwatch, see what time it takes for you to go from the starting of the stopwatch, from watching this video to the time to completely write a working code, because that will ensure and keep you ready for the interviews. And if you get stuck, you can always message or comment below and let me know. Okay, now let's try and understand the time and space complexity. The time complexity of this is 1, right? Even for this the time complexity is 1, even for this it is 1, right? Even for DQ the time complexity is 1, because we don't have a while loop. Because I have kept the head and tail pointers, everything can be done in order 1. Similarly, even in NQ the time complexity is order 1, right? Great. And the space complexity of each operation is not so much important, while the entire circular queue can be stored in order n space. Great. I hope you enjoyed the video. You got the lot of insights which I gave in. Okay, please take it seriously. Maybe you are in a you're watching this probably free right now, this video free right now, or maybe you are watching as a part of a cheaper program, not joined my courses yet, but the value that I am giving here is actually gold. So make sure you probably watch the video a lot of times and focus and emphasize upon what I'm saying. What are these tips and tricks? What's the secret behind them and how you can learn them? Because that's the same secret which will make the difference between someone who spends years and years of time practicing data structures and someone who can just crack these interviews in 1 month, right? And if you have those finances, if you are really serious, right, even if you don't have the finances, gather the finances from somewhere and join the course so that you can master that in just 1 month period or maximum 3 months, right? I'm there to guide you, I'm there to give you that formula, I'm there to help you get unstuck. I'm proficient in a lot of mind hacking techniques also, confidence building techniques also. So the entire system is just ready. All you have to do is just jump into and start working and go to your dream company, get that package and be happy, right? It will make me happy also, because I will have lot more happy students, right? Lot more testimonials, right? And also at the same time will feel very good that I got to help more people, right? So I hope you also enjoyed this video. That's why please like this video right now. Drop comments also below about what you loved in the video, what are those things that you want me to emphasize in the upcoming videos, so that I can know what is important and I will create videos on that. And your comments and sharing of this video will keep me inspired, will motivate me for creating more content like this. Okay, don't forget to subscribe to the channel and don't forget to click on the link and join. Okay, so bye bye, take care, we will catch you in the next one.